Hello there! In this tutorial we are going to be creating this Flappy Bird clone in Pygame. It's ultimately a fairly simple project, there really isn't too much to explain before we start. I guess the one thing I do want to talk about is the folder setup. Here's our game folder and we have 3 subfolders. We have code, graphics and sounds. And sounds is the easiest one, it's just 2 sounds for jumping and the background music. Then for graphics, we have the environment, font, obstacles, plane, and UI. All of these, I think, are fairly straightforward. And then finally, we have the code section. And then here, right now, we have 2 files. We have main and we have settings. And we are going to add quite a bit more in here. But let's go into the code and let's have a look at this. And that's actually bringing us to the very first part of this project, the basic setup. So I'm just going to go over the parts we already have, and once we have that part covered, we can actually start adding stuff to it. So let's have a look. So here we are in the files. We have main.py and settings.py. And settings.py is the easier one. In here, we just have a couple of constants. So we have the width and the height of the window and our frame rate. And besides that, well, nothing else is happening in here. So we can more or less ignore this file. The main.py file is the much more interesting one. And if I run this one, we can see a black window that doesn't really do anything right now. But let's talk about the code really quick before we do anything else. At the top, I am importing a couple of basic things for Pygame. So we have Pygame itself, sys, and time. And then besides that, I am importing settings and all the constants. So that's the stuff we have created up here. And we are using all of this to create a game class. I will explain this one in just a second. But what we are essentially doing is we are checking if our current file is the main file. And if that is the case, we are creating one instance of the game class, and then we are calling game.run. So this really isn't anything complicated. So let's have a look at the game class itself. It's not too difficult, I think. We first of all have a setup part in the init method. And then here we are calling init on Python, we are creating a display surface, then we are giving it a title, and we are creating a clock. So all of this is really basic Pygame. If you have no idea what any of this does, check out my introduction to Pygame. It explains all of this in quite some detail. Now, besides that, we also have a run method, all of this here. And all we really have in here is a while loop, and in this while loop, we are updating Pygame and we are calling the frame rate. Besides that, we also have an event loop, and we are using delta time. If you have no idea what delta time is, check out this video, I have explained all of it there. It's basically there to account for different frame rates. And there's one more thing I would like to do to set up this project. I want to create 2 Pygame sprite groups. One is going to be called all sprites, and this one is going to contain, well, all the sprites, and it's going to draw and update them. And besides that, I want another group that is called collision sprites. And this one is later going to contain all of the things our player can collide with, so the floor and the obstacles. And as a challenge, try to create these 2 groups yourself. All I need to do, let me add another section, let's call it sprite groups. In here, I want to have self.all sprites, and this is just going to be pygame.sprite.group. And then I can copy the entire thing, and let's call the second one collision sprites. We are not going to do anything special with either of them. They are just going to contain some sprites. And all right. With that, we have the first part covered. So now we have a basic setup. Next up, I want to work on the background. And this one, I want to be moving continuously in the background. And that isn't too much of a difficulty, although there are a couple of things we have to take care of. But I guess let's jump straight into it and let's have a look at it. Here I am back in the project, and I want to create a new file that I'm going to save as sprites.py. Because this one is going to contain all of our sprites. And first of all, I have to import Pygame itself. And besides that, I also want from settings import star. So all of this stuff here. Once we have that, I want to create a class that I called BG for background. And this one is going to be pygame.sprite.sprite, a basic sprite. And for this one, when we call the dunder init method, I want to have self, and for now I want to have groups. Although we are going to need one later on, but don't worry about that for now. Now, the first thing we always have to do is call the super, that's not how you spell that, the super and the dunder init method and pass in the groups. So whatever group we pass in here, for example, our all sprites group, then this sprite is going to be allocated to these groups, which is exactly what we want. Now, besides that, we need to set self.image and we need self.rect. And we do have an image. This one we can just import with pygame.image.load. And for the folder, we have to go one folder up. Then we have to go into graphics. There we have environment. And inside of environment, we have background.png. And as always, don't forget to convert this thing. For this one though, we don't need convert alpha because there are no alpha values. And once we have that, for the rectangle, I just want to get self.image.get_rect, and the top left should be at position 0 and 0. So we essentially create an image that we are placing in the top left of the window. So far, this really isn't anything difficult. And I realized I have a typo in there. So back in my main file, I want from sprites import bg, and then after I've created the sprite groups, let's add another section and let's call this one, I guess sprite setup, doesn't sound too bad. And what I want to do in here is to create my background, and I have to pass in the sprite groups. And in my case, this is just going to be self.allsprites. So this argument is for this parameter here. And now, if I run all of this, we can see nothing. For the simple reason that we are not drawing this sprite group. That's the one I forgot just now. So in my game logic, I want self.allsprites.draw on self.display surface. And now let's try this. But now we can see a problem, that this thing is way too small and needs to be much bigger, nearly twice as big actually. So this image here should scale all the way down to the bottom of the window. And for that, we have the scale method, but there's a bit of a problem. So essentially what I want to do, when I import this image, I don't want to set it straight as the image of the window. So let me first import it as another variable. And let's call this one bg_image. And for now, this is going to be the same image. And what I could be doing now is, when I create the image, I could call pygame.transform.scale. What scale essentially does is it takes a surface and a scale. And this scale is going to determine how big the surface is going to be. For example, if I pass in our window width and our window height, let's actually copy those from settings. So window width and window height. And for the surface, I just want my bg_image. If I run this now, we get an image that covers the entire background. The problem now is that all of this is kind of weirdly stretched. You can see it especially at the clouds, so this bit here looks kind of weird. And that's what I want to avoid. And I guess the best way to think about it is to open all of this in Photoshop and explain what we have to do instead. Alrighty, here you can see the entire thing in Photoshop. The black frame is our Pygame window and the blue thing is our background. And you can already see the initial problem that our background doesn't cover the entire frame of Pygame. And what we have done just now with the scale method is to change the scale of this thing to something like this, which does work but stretches the background image quite a bit. So I don't really like that one, so let's undo it. And essentially what I want to do is I want to keep the aspect ratio of this thing constant. meaning that the width of this thing and the height of this thing should keep the same ratio towards each other. So I guess right now the image is always about 1.5 times as wide as it is high. And when I scale it, I want to keep the same ratio, which in practice means I want to do something like this. And once we're doing that, the entire thing is going to look significantly better. But to achieve it, we are going to need a bit of math. But let's do this one straight in code. I think that's going to make more sense. Here I'm back in the project, and the first thing I want to do is to get rid of the scaling method. So let me copy this thing back to what it used to be and copy this one out. And now if I run this again, we can see the thing we had earlier. So let's talk about what we have to do. Essentially, I want to get this image here. So let me just make a square, and I want to multiply this by a certain size. So this is what we need to find out. And the result of that multiplication should be an image large enough to cover this entire height of the window, which in my case right now is 800 pixels on the y-axis. So let's say for simplicity in here, this one should become 800 for y. And this means we have to find this y here. And how can we do that? Let me actually get rid of all of this text here to figure out what we have and how we can use it. So we still know our entire window is 800 pixels high. And we also know how high this surface here is. That's something Pygame can give us. Let's say for simplicity here, this is 400 pixels high. So what we essentially want to know is by how much do we have to multiply 400 to get to 800. Now, obviously, this by itself is a very simple calculation, but we want to make this a bit more flexible. So at the height of this surface could be basically anything and the formula would still work. But really, all we have to do to get this y here is to multiply the height of the entire window divided by the height of the background. This number simply came from moving this 400 down here and then using it as a divider for 800. So very simple math. But all right, let's actually implement this. This number I do want to reuse later on. So I am going to get this number in my init method. You're going to see later on why this is going to become important. And essentially, I want to create another section, and let's call this one the scale factor. And the first thing we have to do in here is to actually get my BG height. And for this one, I want to get my pygame.image.load, and the image I already have, it's this path here. Now, for this one, we don't really care about the image. We just want to know how tall it is or how high it is. So all I want to do is get underscore height. And let's actually print it to see if this is working. So BG height, and if I run this, we get 480. So this entire thing is 480 pixels high. And we want to know by what number do we have to multiply this to get to 800. So x is just going to be 800 divided by 480. And that is a number we can get quite easily. And I want to store this number in self.scale underscore factor. And all I really want to do in here is to get my window height and divide this by BG height. And let's print this one just to see what we are getting. So self.scale factor is, I need to use self. So this now, it's 1.66. And this is the number we can now use to create this BG. So I want to pass in self.scale factor in here. Now in my sprite class, I can create another parameter that I'm going to call the scale factor as well. Now, the first thing I want to do is to uncomment bg.image. And first of all, I want to get my full height and my full width. And only once I have those, I want to use pygame.transform.scale. And in here, I again want to use my BG image. But now for the scaling part, I want to get my full width and my full height. And now let's do an exercise. Try to figure out for yourself how to get the full width and the full height of the BG image that we are going to need. And here again, the important part is you should scale both of these sides by the same number, so the same scale factor. All I have to do is to get my BG image and then get for the height, get the height. And this number I then want to multiply with the scale factor. And once I have that, I can do the same thing for the width. So BG image, except now I need to get the width of this thing and multiply this one by the scale factor as well. And now we should be good to go. Let's try this now. And there we go. This is looking significantly better. So now our background does cover the entire image, but it's not stretched in a weird way. So this is working quite nicely. And let me get rid of this print statement here. It doesn't seem necessary. So now that we have that, let's animate it. And this also happens in the sprite class. All I really want to do in here is to give this one an update method. It needs self and it also needs delta time, because whenever we move anything with delta time, it has to be multiplied with delta time. And on top of that, I also have to create self.position. And this is something I've explained in my delta time video, that when we're using delta time to move, we can't really store the position in the rect attribute anymore, because this one only stores integers. But when we use delta time, we get lots of floating point numbers. And if we store all of them as integers, we would get inconsistent movement. So I want to store all of this in a position that is just going to be a vector. So pygame.math.vector2 and self.rect.top left. So by default, we're getting a vector in position 0 and 0. And now all I want to do is self.pos.x minus equal some kind of speed. Let's say in my case, 300 seems like a good number. And this I want to multiply with delta time. And once we have done that, I want to get my self.rect.x is going to be round self.pos.x. And if you're used to normal Pygame, this does seem kind of annoying, but it's the only way to get consistent movement with delta time. Although granted, it is a bit tedious. But alright, so now we should be having some basic movement once we are calling the update method. So before I am drawing all of my sprites, I also want self.allsprites.update. And now if I run this, we are getting an error that I forgot delta time. Now let's try this again. And there we go. We have some decent looking movement. Although there we have a problem that at the end we get something weird. And the problem here is that I didn't fill the screen with any kind of color. So self.displaySurface.fill, and let's just fill it with a black color. And now let's try this again. Now you can see what's going on. So the image is moving just fine, but now the image is moving too far to the left. The problem essentially being that this thing keeps on moving left perpetually, but we never stop it. So at some point it is going to leave the screen. And this is kind of easy to change. All I really want to do is if self.rect.right is smaller or equal to 0. Actually, let's look at this in Photoshop. So here you can see the entire thing again. And what we're doing right now is once this background is here, I want to set it back to this position here. So in the if statement, we are essentially checking if we are on this position, then I want to set the position of this background back to 0 and 0. So once right is smaller or equal to 0, Then I want to set self.pos.x back to 0. And now this self.rect.x has to be all the way at the end of this. So now if we run this again, we can see this is kind of working with one exception. There we go. That we always can see the black background for a while, which isn't ideal. As a matter of fact, it's unacceptable. So let's talk about how we can change it. And this, I guess, is best again explained in Photoshop. So here's what we have just done. We have the background image and we're moving it further to the left. But once it is all the way to the left, you basically can see the background, which, well, looks terrible. Now, the way to overcome this is to simply copy the background and paste it twice, like this. So we have the same background exactly on the right of the original background, and we're always moving them together. So now if I move these two things together, and I just keep on moving until I hit the right side of the original one, then you can see the second background. But now, if I again move this thing to position 0 and 0, then you can see the original background. And since both of these are identical, this image is going to be the same. So the player shouldn't be seeing a difference. In practice, all we really have to do is to duplicate our background image and make it twice as wide by copying the original image, which is honestly a very simple thing to achieve. Here I'm back in my code. And in my sprite, I want to create a new self.image that is twice as wide as the original background image, and then place this background image on that twice, one on the left side and one on the right side. And for that, this self.image, I'm going to rename to full-sized image. So this is the fully sized image that I want to create twice. And now my self.image is just going to be a pygame.surface. And in here, I have to get a width and a height. And the height is very easy to get. I just want to get my full height, which is essentially the number I get from here. But for my width, I want to get my full width and multiply this by 2, which is this number here multiplied by 2. And this way, this self.image is going to be twice as wide as this background image. Or well, rather, this background image at its full size. And once I have that, I want to get self.image.blit, and I want to paste the full-sized image at position 0 and 0. And then I want to do this again, but now I want to paste this on the left side being the full width. So essentially what we have done is we have created a surface that is twice as wide as the original background image. And into this, we have pasted background image once at position 0 and 0. So this point here is essentially this point here. Once we have that, we have blitted the same surface on the right side of this original surface. So this point here is this full width. And with that, we have a double background. And now what I want to do, I don't want to check anymore if the right side of this rectangle is to the left of the screen. Instead, I want to check if the center X is to the left of the screen. Actually, let me reopen the image we just had. So this is our new surface. And we now know that these two surfaces are identical. So we don't want to check this right side. Instead, we want to check the center X, because we know that this is the end of the original surface. So this is now what should be working. Let's try all of this. And now let's just keep it running for a couple of seconds. And I think this is looking really good. And yeah, I am quite happy with this. So this is looking just fine. And all right, with that, we have a background. Now, next up, we can work on the ground. And the ground is going to work in basically the same way as the background, it's actually a tiny bit easier. The reason for that is that I already doubled it in Photoshop before this tutorial. I am going to explain in a second why that is. Let's first implement it, and then I'm going to explain what's going to go different. Here we are back in main.py, and in my sprites, I want to create another class. This one I called ground. So let's import it straight away. And in my sprites class, let's minimize class.bg. And I want to create class ground. And this one is going to be pygame.sprite.sprite. And in here, I want to create an init method that again is going to need self, groups, and the scale factor again. Oh yeah, and this is also something I didn't really explain yet, that we need to use the scale factor here again. And let me explain right now why. So when we scaled the background, we also want to scale the ground by the same number, so that those two stay relative to each other. And the BG is what determines how big the scale factor is going to be, which is why we get the scale factor essentially from this number. But later on, we're also going to scale the plane and all of the obstacles by the same number. And this is important to keep the game consistent. So I hope that makes sense. But all right, now we have those numbers. I again need super and dunder init, and we pass in the groups in here. Now, once we have that, I want to get my ground, let's call it ground surface. And this one is going to be pygame.image.load. And in here, we need a string that goes upper folder to graphics. Then we have environment, and in there we have ground.png. And for this one, we need to convert alpha. That's actually really important. And now this ground surface we want to use for self.image. And from self.image, we are going to get self.rect. All we have to do for the image is to get this ground surface and scale it by the scale factor. And we could do this in the same way we have done for the BG class. So we have a full height, a full width, and a full-sized image. Although that's 3 lines of code, it's a bit much. So instead, what I usually do is pygame.transform.scale. In here, we do need our ground surface, but for the scaling, what you can also do is to get the ground surface and get underscore size. And this, I just want to multiply with the scale factor. Now this by itself wouldn't work because we can't multiply a tuple with a number, but we can multiply a vector with a number. So I'm going to turn this tuple here into a vector. So pygame.math.vector2, and now this would be working just fine. And this puts the entire logic into a single line, which I think is much cleaner. Now for the rectangle, all I really want to do is self.image.getRect. And for the position, we now have to think about what we are doing, because I can't just put top left at 0 and 0. Actually, I can, but it wouldn't really work. Let's actually try and see what happens. So in my main.py, I also want to get the ground. So let's create the ground. And the ground for now is just going to be in self.allsprites and self.scale factor. And if I run all of this, we can see why this isn't working. The ground is way too high up. So this is no good. And fixing this shouldn't be too hard. And I think this could actually be a fun challenge. So try to change this argument here in such a way that our ground is always at the bottom of the window. All right, all I have to do is get the bottom left, and that's the position I want to place. And now for this one, the X is going to be 0 by default. But for the bottom height, I want to get my window height, I believe I called it. So right now, this is this number, 800. And with that, we're placing the bottom left at the bottom left of the window itself. And now let's try this again. And that is feeling much better. Cool. And let me just clean this thing up a tiny bit. So let's call this the image. And then for the rect, let's call it the position. And I guess while we are at the position, we can also animate this thing. And for that, we again are going to need self.pos. And just like we have done before, I want to get pygame.math.vector2 spelled correctly. And then here self.rect.topleft. And now I want to create an update method again that is going to be self and delta time. And really, all I want to do in here is self.pos.x and then minus equals some kind of number that ideally should be different from this 300, so that those two move at different speeds, which look a bit better. And I went with 360. And don't forget, multiplying this by delta time is really important. And now, if self.rect.centerx is smaller or equal to 0, then self.pos.x is going back to 0. And then finally, self.rect.x is going to be rounded self.pos.x. And that is essentially all we needed. Now, what you could have done is use inheritance because those two numbers are nearly identical. That would have cleaned this thing up a tiny bit, but well, do it in your own time if you really want to. It's not that much that it would really justify that much extra work. All right, let's try this now. And there we go. Now all of this thing is moving and it never stops moving. Cool, that looks good. Now you might be asking yourself, why did I double the size of this ground surface in Photoshop? And for this background image, we're doing all of this in Pygame. So this line here. And the answer is, later on for the ground, I want to use a mask to check the collision between the plane and the ground. And if I created this self.image, this kind of interfered with the mask, which was kind of annoying and broke the entire game. So this is kind of a workaround. It's not ideal, but it does work. So I hope that makes sense. But all right, so with that, we have our background and our ground. So next up, we can actually start working on the plane itself. Then the game is going to look much nicer. So let's talk about the plane. And this one needs to do a couple of different things. It first of all has to animate so that we can see different frames after a certain amount of time. Besides that, it also needs to fall down and be able to jump, and the jump is going to be determined by player input. And finally, we also need some kind of rotation mechanic. And later on, we also need collision, but that, well, we are not going to worry about right now. So what we're going to do for now is create a basic plane that doesn't collide with anything just yet. And let's do all of this straight in the game. I think that is the easiest. So here I'm back in my main file, and I want to go to my sprites and create a new class that I have called plane. And this one, again, is going to be a sprite.sprite.sprite, spelled correctly ideally. And in here, for the init method, I again want self, my groups, and the scale factor. And the first one we need in here is super, and then the dunder init method, and passing in the groups to allocate the sprite. Now, what we are going to need. We have to figure out some kind of image, and later on some kind of rect for the positioning. And for the image, we want this to be animated. So I have to import a couple of frames first. And this I want to put in its separate method. So self.import_frames. And in here, every time I import a surface, I want to scale it immediately. So I want to pass my scale factor in there. Now, besides that, I also want to have self.frame index, and this by default is going to be 0. So essentially what's going to happen is that this import frames is going to import a list of surfaces. And this frame.index we are going to use to pick one of these surfaces. And then for my self.image is just going to be self.frames, and we're going to pick self.frameIndex. And later on, this frame.index we are going to increase to pick another frame. And that way we are going to animate this thing. And once we have the image, we can create self.rect, and this is just going to be self.image.get_rect, and this shouldn't be capitalized. And in here, we have to think about where we are going to place it. And let me draw this out actually. Let's say this is going to be our entire window. And I want the player starting position to be here-ish, where the center of the thing is roughly in the middle, or well, exactly in the middle, and the X position has some kind of offset to the left, so we're not right at the left edge of the window, but there should be quite some space to the right of the plane. So we have to figure out this positioning here. And basically what I have done, I am placing the mid left. So I am placing this point here. And for this point, let me actually get rid of all of this. We need an X and a Y position. Now, the X is the easier one. I just want to get my window height and divide it by 2. For the X position, I essentially get my window width, and I divided this by 20. If this here again is our entire game window. Right now we have this entire distance is our width, and I think right now this was 480. And if I divide this by 20, we get to 24, which is roughly this distance here, or 1/20th of the entire width of the window. And this distance then is going to be the left side of my plane, which does give it a nice offset from the left side. And that's also relative to the entire window. So if the window gets very large, this still works. And now that we have that, the last thing we have to do to get started is to actually create the import frames method. And need self and the scale vector. And essentially what I want to do in here, first of all, I want to create the attribute self.frames, and that's just going to be an empty list. Now, once we have that, let's actually look at our folder. And that one is this one. And in my graphics, I have a plane. And in the app, we have red 0, red 1, and red 2. So essentially what I want to do is create a for loop that runs 3 times and imports all of these 3 images and places them inside of this frames as the scaled surface. And this, I think, could be a pretty fun exercise. So try to import these 3 images of the plane, scale them, and put them in the surface in the self.frames list, and see how far you get. First of all, I need for, let's say, I in range 3. So we're running the code 3 times. Then I want to get a surface, and this is just going to be pygame.image.load. And in here, I first of all want to get the string itself. And we go up one folder, then graphics, then plane. And inside of that folder, we have red. And this could either be 0, 1, or 2. And this is the same information I get from my I here. So I'm going to turn this string into an F string and place in the I in here. Now, after that, don't forget, this is a PNG file. And also, I want to convert alpha all of this. So now we have a surface. Next up, I want to create a scaled surface. And this is going to happen in kind of the same way that I have done up here. So I'm going to use transform.scale, get the surface, and then use a vector to scale it up. And we want pygame.transform.scale again. I want to place in my surface. And then for the scale, I want pygame.math.vector2. and my surface.get_size. And then this number I am going to multiply with the scale factor. And then just realize this scale factor should be outside of that. That is looking better. All right, and now that we have that, self.frames.append and the scaled surface. So now that we have all of that, back in my main file, all the way at the top, I can also import the plane. And let me spell it properly. And then I can create plane, and all the parameters we need are the groups and the scale factor. So I can just copy them from the ground. They didn't change very much so far. And now if we are running all of this, we can see a plane. Although you might see that this is way too large. So the problem here is that the scaling behavior of some of these images are a bit, well, if they're scaled too much, it looks a bit weird. But that's not that difficult to fix. All you really have to do is divide this scale factor by a certain number. In my case, I divided it by 1.6. And if I run it now, this feels much better. Could even be a little bit smaller, let's say 1.7. Yeah, I guess that even feels better. And I guess depending on your resolution, play around with this number and see what looks best. This is partly subjective and partly depends on what you feel is best for the game. So just see what feels good and I'm sure you'll be fine. But alright, so now we have a plane. And I guess now we can start working on the gravity and on the jumping mechanic. And for that, since we are going to move the plane, I want to give it a self.position again. That is going to be a pygame.math.vector2 and self.rect.top left. And now we are going to need two more things for the movement. And let me put those in a separate part. Let's call it movement. And first of all, we need some kind of gravity. And in my case, gravity is 20. And then besides that, I also want to get self.direction. And this by default is going to be 0. And the reason why we need direction is because our plane can go up and down. Whereas for the ground and for the background, they always went in the same direction. But for this one, it's slightly different, which is why we have a direction. But now that we have that, we have to create a couple of methods. I guess the first one we can start with is define update. We need self and delta time in here again. And in here, ultimately, I want to create 3 different methods. They're called self.gravity, then I have self.animate, and finally self.rotate. And what is important is that all 3 of those are going to need delta time. And for now, I am only going to work on gravity, so let me comment out the other ones. So let's create the method gravity. And we need self and delta time. And the really important thing you always have to understand about gravity is that gravity is not linear. And all this really means is, let's say you're standing on a cliff and you're here and you're jumping down, you don't fall like this, you fall something like this, where the longer you fall, the faster you fall. And this is also what we want to include in here. If we didn't, it would look very weird. And the way this is usually implemented is we first get our self.direction and we add towards it our self.gravity. And remember, this needs to be multiplied with delta time. And now this direction, we are going to also add towards our position.y. And this also has to be plus equal. And in here, we are going to add our self.direction. And this one is also going to be multiplied with delta time. And now, finally, self.rect.y is going to be the rounded version of self.post.y. And I guess let's try all of this. So now things are not working. Let's have a look. The problem I have made right now is that we have a method called gravity and we have an attribute called gravity, which is not great. So let me rename gravity to apply gravity. that even makes a bit more sense. And now our plane is going down ever so slightly. I guess the amount is a bit low, and I guess 20 is a bit low. Let's set this to something like 250. I think that's going to be better. And there we go. That is more appropriate. All right. So with that, we have a plane that is falling down. Now, to counteract, we have to give it the ability to jump. So that's going to be the opposite of gravity. And this is just going to be another method that I called jump that only needs self. And all we really need in here is set our self.direction to something like, let's say, -400. And let's see how far that gets us. Now, the only thing we have to figure out is how to call this kind of method. And this we could do in two different ways. We could either run a method inside of here that would be perfectly fine. Although in my case, since we're only checking for one simple thing, I am going to look at my event loop. And in here, I'm going to check for if event.type is going to be equal to pygame.mouse button down. So whenever we click the mouse button, I want to run this jump method here. Now, for that to work, we need to figure out where our plane is. And right now we can't. It's just one sprite inside of all sprites. But we can just assign this self.plane to an attribute, and now we can target it right away. So all we have to do now is self.plane.jump. And that is all we needed. Now let's run the code. And we're getting an error because this needs to be a comparison operator. And now if I run this is kind of working, although I think the gravity is still a bit too weak. So let me change this 250 to something like 600. And now this feels much more responsive. Okay, you can play around with the numbers here. So the gravity and the jump speed, just play around with those and see how far you get and what feels best. There isn't really an objective answer. It really depends on how you want your game to feel. But all right, with that, we have our player movement. Now, next up, we have an animation and a rotation. And I guess let's work on the animation. And this is just going to be another method with self and delta time. And the basic idea how this is going to work is we are going to do the same thing we have done up here. That we have a frame index, and we are going to use that frame index to pick one frame from our frames. So this is a list of surfaces. And pretty much what we are going to do, we are going to always increase on every single frame our frame index by a very small number, let's say by 0.5. Now, if you do this only once, you would get to 0.5 and you couldn't use that number for an index. So what we are going to do is we are going to take the integer of this number, which in practice means we are going to get rid of anything after the period. So we are going to get to a 0. So on the first frame, if we add 0.5, we're going to stick to a 0. But if we're doing this twice, this 0.5 would become a 1. And then our frame index would take the next surface. That's the basic idea. And how this is being implemented is we are first going to get our self.frame index, and we're going to add some animation speed. Just to get some number, let's go with 5. And remember, this also needs to be multiplied with delta time. And basically now what I want to do is self.image is going to be self.frames. And in here, we want to get the integer of self.frame index. And this would work, but we would run into an error really fast. And let me explain why. Right now, we have a folder with 3 surfaces. We have 0, 1, and 2, or red 0, 1, and 2. And by default, we are starting with our index of 0. So we keep on increasing this number. At some point, we get to 1. At some point, we get to 2. Now the problem we have is that we keep on going. So our frame index would sometimes reach 3, then we would get to 4, then to 5, and so on. And these numbers don't exist in our list. So Python would be very unhappy and give us an error message. Which means in practice, what we have to do is after we have crossed a 2, we want to go back to 0. So we are looping back to the first item in this list. And that is also fairly easily done. All we really have to do is if our self.frame index is greater or equal than the length of our self.frames. And if that is the case, self.frame index is going to be 0. And that is all we needed. So now back in the file. Now we have an animation. It's a bit slow. I guess we can make it a touch faster. Let's change this 5 to a 10. Let's see how that looks. And yeah, I think this is all right. Possibly still a bit slow, but again, play around with this and see what you like the most. So, all right, let me minimize all of these methods so they don't get in the way. Actually, let's do this one here as well. And now, finally, we have to work on the rotation. And again, another method with rotate and self and dt. And the first thing I want to do is to create a new variable with rotated plane. And this one is going to be pygame.transform.rotozoom. Now, in Pygame, you have a couple of different methods that can rotate. Rotozoom, I think, is the one that tends to look the best, because this one applies a certain kind of filter that makes things look a bit better. And this method needs 3 different arguments. We first need a surface, then a rotation, and then a scale. Now in our case, the scale we don't care about, so this is just going to be a 1, meaning that we don't want to scale anything. Now for the surface, I just want to get my self.image. And finally, for the rotation, I just want to get my negative self.direction. So the idea here is that the faster we are falling down, the more we want to rotate clockwise. Let me actually draw this. I think it's going to make more sense. Let's say this one here is our plane. And if we are going down, I want this thing to rotate this way, so clockwise. And if we are going up, then I want to rotate counterclockwise. And because of that, I want to link my rotation to my direction. And what you might have noticed here as well is there is in all of this not a single delta time. For the simple reason that we don't actually move anything here, at least not directly. We're just setting the rotation relative to the direction, but we don't rotate anything by itself. But with that, we can remove delta time from the rotation because we don't need it. And now all I have to do is self.image is going to be the rotated plane. And well, let's try this. And well, it's a bit high. Now, the problem here is that this self.direction is quite a large number. So we want to reduce it by, let's say I want to multiply it with 0.06. And now if I run this is feeling much better. And that is looking quite good. So now we have the rotation, the animation, and the movement. And there's one important thing you really have to understand here. That the order of these 3 methods really matters. At the very least, the animate method should come before the rotation. And I guess, let me rotate them around to see what happens. We don't get any kind of rotation at all anymore. The reason being here is when we rotate something, we are setting the image. And whenever we animate something, we are creating a new image, which effectively means we are overwriting anything inside of the rotate method. And as a consequence, rotate would become basically pointless. So just keep rotate after animate and you should be good to go. But all right, with that, we have our plane. And let me run it again. And this isn't looking bad at all. Cool. So now we can start working on the obstacles. And here again, the obstacles really aren't that difficult. So let's jump straight into the code and let's have a look at this. We are back in the main file, and I again want to go to my sprites and create a new class that I called obstacle. It's also sprite, so pygame.sprite.sprite. And again, we need a dunder init method that needs self, groups, and let me spell it properly, and the scale factor. And first of all, in here, we again need the dunder init method and pass in the groups in there. And now in here, we have to get, as always, self.image and self.rect. But now we have kind of a problem. Let me actually open the folder to illustrate what's going on. So here's the folder with the obstacles, and we have two different kinds of obstacles. First of all, we have 0 and 1. And I want to pick a random one of those two. But besides that, I also want to randomly make those two either pointing upwards or pointing downwards. And all of this I have to create in the init method. So the first thing I want to do is figure out or randomly allocate the orientation. And since we now need random numbers, I want from random import choice. And my orientation is just going to be choice between up and down. Now, for the image itself, we are still going to import the image. But I guess, first of all, let's move this one down. And I want to import the surface by itself. So pygame.image.load, and let me fix the typo. And in here, we are looking at the folder that goes one folder up, then graphics, then obstacles. And in here, we have either the image 0 or the image 1. And I want to pick one of those at random. So I have to turn this into an F string. And then in here, I want to get choice. And in choice, this should either be 0 or 1. And now, again, don't forget, this has to be PNG. And at the end of this, we want to convert alpha, all of this. And now we have to do the same thing again with pygame.transform.scale. I want to get my surface, then pygame.math.vector2, the surface.get_size, and then multiply all of this with the scale factor. And all right, with that, we have our scaled surface. But now let me move the rectangle a bit further down. I want to check if my orientation is equal to up. Then I want to leave my surface as it is. So let's say for now I want to add a path in here. But if that is not the case, so if the orientation is down, I want to create self.image, and the new image should be this image but flipped around. And this we can do with pygame.transform.flip. And in here, we need 3 different arguments. We need the surface, we need a horizontal flip, and we need a vertical flip. And both of these are going to be Boolean statements. Now, in my case, for the surface, it's just going to be self.image. For the horizontal flip, I want to set this to false, because I don't want to flip it in this direction. But for vertical, this should be true. So with that, there's a 50% chance that we are flipping the entire image. So with that, we have to figure out the rectangle. And now we kind of have a problem. And let me draw this really quick. If this again is our entire window, if our orientation is downward, we want to spawn the mountain somewhere here. But if the orientation is upward, we want to spawn the mountain at the bottom of the window. So we have different kinds of origin points depending on our orientation. Hence, we can't just create a rectangle for every orientation. So instead, we need one rectangle for up and one rectangle for down. So I want to have self.rect in here, and I also want to have a self.rect in the else statement. And in either case, I want to get self.image.getRect. So that part stays the same. But now we have to figure out which point to place. And in my case, I think what makes the most sense is if the orientation is up, I want to place the mid bottom. And if the orientation is down, I want to place the mid top. So back in my drawing, essentially what I am going to do is if the orientation is up, so we're in the bottom one, then I want to place this point here. And if the orientation is down, I want to place this point. That way I can just use 0 or the screen height. But now I have to figure out for both of these an X and a Y position. And this, I think, could be a fun exercise for you. So try to figure out the X and the Y position for both orientations and see how far you get. The X position for both orientations is going to be the same. So I'm going to create that before the if statement. And basically what I want to do in here is I want to get my window width and then add a random amount of space. So I want to get a random integer, let's say between 40 and 100. And since we're using randint, we have to import that one as well. And the entire idea for this one is if this is our entire window, we are getting this entire width, which brings us to this point here. And then I want to have some kind of offset here that is a bit random. And that way our game looks a bit more organic. But that's all it is. Now, for the Y position, we have to do this for each orientation. So the Y, if we are looking up, is just going to be the window height. And here again, I also want to add some random amount. Let's say between 10 and 50. And this is going to be the same logic that you have just seen. Let me move this a bit up. So what we want to do is to get to this point down here and wiggle around that point. So we want to be in this area here. And to get there, we essentially need to get the entire height of the window and then add some random amount to it, which is exactly what we have done down here. And now finally, for the downward facing orientation, Y can just be randint. And in here, let's go with -50 and -10. So technically, to make this in the same style as this one, we could say 0 plus randint. So 0 is the top of the window, and from that, we are adding some negative numbers, so we're going up by a tiny bit. But, well, we don't need the 0. I hope this makes sense. And, all right, with that, we have an obstacle. What we can do now is give this thing an update method straight away. This should be here. This one needs self and delta time as always. Oh, and what I just forgot, we have to set self.position again. And this again is going to be pygame.math.vector2 and self.rect.topleft. And now, basically, all I really want to do, self.post.x minus equal, let's say 400 times delta times. And then self.rect.x is going to be rounded self.post.x. And that way, this object is going to continuously move to the left. Now, there's one thing I do want to implement straight away. And that is if this entire sprite goes too far to the left, I want to destroy it. And if we don't do that, at some point we are spawning too many objects and the game will slow down. So all we need for that is if self.rect.right is smaller or equal to, let's say, -100. And this means that the right side of the sprite is 100 pixels to the left of the left side of the window. The player will definitely never see it again. And if that is the case, we can run self.kill. Now I guess technically this number could be 0, but I do want to have a bit of a wiggle room here. But alright, with that, we have the entire obstacle class. That's kind of all we needed. But now what we have to figure out is how to spawn this obstacle, because we want to spawn this one continuously. And for that, we are going to need a timer. So let me add another section here that I call timer. And first of all, we need to create an obstacle timer. And this one is going to be pygame.user event. And don't forget, this always wants a plus number by some integer. So in my case, just +1. And once we have that, I want to start this timer. So pygame.time.set _ timer, then self the obstacle timer. And now we need to figure out how often this timer should run. In my case, 1400 milliseconds, so 1.4 seconds felt like a good number. And now with that one, in our event loop, we can actually check for this sort of event. So in here, if event.type is equal to self.obstacle timer. And if that is the case, I want to create an obstacle that shouldn't be all capitalized. So I want to create one instance of this class. And I guess for that to work, we first of all have to import it. So obstacle. And now in here, we again need two different arguments. We need the groups and we need the scale factor. So self.allSprites and self.scale factor. And that should be all we needed for now. So let's try this. And there we can see one mountain, another, and there we can see some downward facing ones. This is working just fine. Cool. I am quite happy with that. Now, if you want to make the game harder here, you could make this scale factor actually a bit larger. So for example, if you multiply this scale factor with 1.2, I think the game becomes really hard. So now the mountains are 20% larger, which makes the whole game quite a bit difficult. So let's leave it at, let's say, 1.1. But again, here, play around with the numbers. But all right, with that, we have our mountains, we have our plain, we have all of the background. So what we can start working on now is the actual interaction between the plain and the mountains. And the one important thing we have to consider here is that we are going to need a mask. But I guess this we are going to talk about when I actually implement it. So let's go straight to the code and let's have a look at this. Here I am back in my main file. Now there's one thing I first have to do. That right now I have all of my sprites. So all of my obstacles, all of my, my plane, my ground, and my background, they're all in all sprites. But for the collisions to work properly, I need to have first of all one sprite, my plane. This one I already have. But now I need a group with all of the obstacles my plane can collide with. And this I don't have right now. Oh well, I have it, it's my collision sprites, but this collision sprites is empty right now. Because for now, I always put all of my sprites inside of all sprites. But this we can change fairly easily. So the ground should be in all sprites and self.collision sprites. And this thing I want to copy now. And also the obstacles should be both in the all sprites and in the collision sprites. And these collision sprites I will use only for the collisions. They don't really do anything else. So now that I have that, I can create another method that I just call collisions. In here we need self and nothing else. And for now, I just want to check if there's any kind of collision between my plane and my obstacles. And this happens with pygame.sprite.sprite collide. And in here, we need one sprite, we need a group, and we need what is called doKill. The sprite is the one sprite we want to look at. In my case, this is myself.plane. The group we want to look at is self.collision sprites, I think I called it, yeah. And do kill means if this sprite here collides with any sprite inside of this group, do we want to destroy that sprite inside of this group? Now, in my case, it actually doesn't matter because we want to crash the game as soon as there's any kind of collision. So in my case, I went with false, but it really doesn't matter. And I guess just to test this, let's put this entire thing inside of an if statement. And if that is the case, let's say pygame.quit and sys.exit. And now we can call it, let's say after the update method, so self.collisions. And let's see what's going to happen. So the game doesn't throw an error, and that looks pretty good. I can also just fall on the ground, and this also looks pretty good. So this is working pretty well. However, it's not actually working well. And let me actually play it again. And if I play this for a while, so there you could see we didn't really touch any of the obstacles, but the game still ended. And the reason for that is this. Let me give a bit of space. Our obstacles look something like this. They are some kind of mountain. But if we just use this kind of collision mechanic here, we are using rectangle collisions. So Pygame essentially draws a rectangle around this mountain, and that is going to be the collision, which in our case is a pretty substantial problem because these areas here shouldn't count as a collision, but right now they do, which makes the game basically impossible. Also, our ground looks something like this. So technically, if the player is here, for example, the game shouldn't end. But since we are using rectangles, our actual rectangle box to check the collision is something like this. So even if the player is in some kind of valley, the game would still consider this a collision right now. So all of this combined, this isn't really working right now. And the workaround we have to go with is mask collisions. Now, I have made a whole tutorial exclusively on how to use a mask for collisions and for basically anything else in Pygame. So check this tutorial if you want to get an in-depth look at this. But in the most basic sense, a mask just collects all of the pixel positions of each of our sprites and then checks the collisions between them. It's really easy to implement. And well, let's do it right now. So I want to get a mask for my plane, my obstacle, and my ground. And I guess the ground is the easiest one. Let's start with this one. We actually only need a single line of code. And let me add another comment here, mask, and we have to add self.mask. And this has to be called a mask. You cannot give this any other name. And now to get our mask, we need pygame.mask.from_surface. And then here, we just need a surface, and in my case, this is going to be self.image. And now we have a mask for our ground. And this line, I can actually just copy and minimize the ground. And for the obstacle, I can just add a mask in here at the end. That's basically all we needed. So we can minimize this one as well. Now for the plane, things get a bit more complicated. But first of all, when we call the init method, we need our mask. So it has to be in there as well. The problem for the plane is that we are updating this surface, so this surface here, quite a bit before we are actually drawing it. So this animate here and this rotate here in particular change the actual surface. And in practice, think of it like this. If this is our surface for the plane when we are finishing the animate method, then we have a mask that's going to look basically identical to this. But now when we call the rotate method, so the one all the way at the end here, we might get something that looks like this. And as a consequence, if we didn't account for this new surface, we might get a collision here, for example, or all the way up here, which might be frustrating. So after we are doing a rotation, we want to set a new mask. And this is done by just creating a new mask here, or while updating the attribute. And well, that is actually all we needed. So now, Each of our main sprite, our ground, our plane, and our obstacle, each have a mask. The only sprite that doesn't need a mask is the background, because this one doesn't have any collisions. But now, if we run all of this again, we still can't see any kind of difference, so the collision still breaks. The reason for that is that sprite collide is going to need one more argument, and that is going to come right at the end. And what we have to add in here is pygame.sprite.collide_mask. And now this should be working. So now, okay, terrible example. Now let me move down here. You can already see it there. So now I was definitely in the bounding rectangle box of these obstacles, but the game didn't crash. Only when I actually flew into an obstacle, the game did crash. So this seems to be working just fine. Now I guess while we are doing the collisions, there's one bug in our game. It's not really a bug, but if I just go all the way up and keep on clicking, the game basically, well, we never collide with anything because we're on top of the entire game. So this isn't exactly helpful. And to account for that, all I really have to do is extend this if statement and add or self.plane.rect.top is smaller or equal to 0. So we want to trigger a collision if the plane collides with an obstacle or if the plane goes too high. And now let's try this again. If I go all the way to the top, the game crashes. That way the player cannot circumvent all of the obstacles. Now with that, we can actually work on the final part, that we want to display a score, and if the player has been crashing into something, we want to get some kind of game over or restart menu that also shows the score. Oh, and I forgot, after this section, we're also going to add some sound, but that is really easy to implement. So let's work on the score and the game over screen. Here we are back in our main.py file, and I want to start working on displaying a score. And for that, we need a couple of things to get started. Most importantly, we need some kind of font. And this I'm going to do in the init method. So in here, I'm going to add another section. Let's call it text, I think makes the most sense. And in here, I want to create a self.font. And this we get with pygame.font.font. And in here, we need 2 bits of information. We need a font itself and a font size. Now the font size is just an integer. In my case, I went with 30. And for the font itself, we will need a file. And in my case, this one looks like this. And if you open up the project files, you have to go to graphics. Let me move it down a bit. And there we have font, and there we have BD cartoon shout, and that's a true type font file, or TTF. And that is what we're importing in here. Now, besides that, we also need a score attribute to save the font, which in my case is just score that starts at 0. And that is basically all we need for now to get started with the score. Now, to display it, I want to keep all of this in a separate method. So let's call this one display score. And in here we need self and nothing else. And now we have to figure out how to get a score. And there are different ways of getting the score. So one method could be that we get a +1 in our score whenever the player crosses an obstacle. Another way would be to just measure the time since the game started. And that's the one I went with, but honestly, all of these methods are fairly easy to implement. So choose whichever one you prefer. But in my case, I am just going to go with time. And well, all we really have to do is get our self.score. And then here, to get the time since our game has started, is pygame, spelled correctly, .time.get_ticks. And this is going to give us milliseconds. But for now, let's just keep it so you see what we actually get. Now, once we have that information, we want to create a score surface, and we want to get a score rectangle. And then basically all I want to do is self.displaySurface.blit, and then the score surface and the score rectangle. So we have to figure out the score surface and the score rectangle. And I think this could be a pretty good exercise for you. So the score we have right now is a text. Turn this text into a surface and from that surface get a rectangle, and then blit both of those on the display surface, and see how far you get. To turn a string into a surface, we first of all need our self.font, so the font we have created up here, and then we need render. And in render, we have 3 bits of information. We need a string, we need anti-aliasing, and we need a color. And let's go through them, I guess, from the start. Our string is just our self.score. The problem is, I actually misspoke. This isn't a string, it's an integer right now. That gives us the milliseconds since the game has started. So we have to turn this into a string, which isn't very difficult. I am just using the string method. You could also use an f string, it really doesn't matter. Next up, we have anti-aliasing. And this basically means if we want to apply a filter to the text to make it a bit more smooth, which in my case, I do want to do. And the only time you don't want to use this is if you have pixel art, because then it makes it kind of weird. But if you have anything else, you do want this to be true. And finally, for the color, I kept it simple and went with black. And with that, we have a surface. Now, next up, to get the rectangle, we want the score surface.get_rect. And in here, we have to figure out a position. And let me illustrate what I want to achieve. Let's say this here again is our entire display. And I want the score to be up here while the game is active, which specifically means that I want the middle of the window in the middle of the entire window. So this is the width of the window divided by 2. And then I also want some kind of offset from the top. And this is some reasonably large number. It doesn't really matter specifically what it is. The middle part here is much more important. To get to that point, I have placed the mid top. And for the mid top, we need X and Y. And X is the easier part. For this one, I just got the window width and divided that one by 2. And for the height, I just went with window height divided by 10. So that the top of the text is 10% from the top of the window. That's kind of all that means here. And that is all we needed for the basic thing. So now we just have to call this method. Let's do it after we're drawing all of the other sprites. So self.display_. And let me add a bit of white space. And it's actually really important that this display score comes after all of the sprites drawing, because this one draws on a display surface. If we are calling this before this method here, we wouldn't see it because the draw method draws the background on top of it. So the order here does matter. But all right, let's run this. And we can see we have a score except one that gets way too high, way too fast. So this is not ideal. And the reason here is that this number is giving us milliseconds instead of seconds. And well, to change that, all we have to do is to floor divide this by 1000. And now let's try this again. And this is feeling much better, except I am terrible at this game. So this is feeling, well, it is working. Cool. So with that, we have a score. Now, next up, I want to work on the game closing down as soon as we have any kind of collision. And instead, I would rather have some kind of game over screen, and then if the player clicks again, the game restarts. And that is also fairly easy to implement. Now, basically, in my game, I want to have an attribute that I called self.active. And this is essentially going to track the status of the game. So if we have crashed into something, it's going to be false, and once we're restarting, self.active is going to be true again. So essentially, once we have a collision, we want to make some changes to this. And specifically in here, I want to have self.active is going to be false. So now, instead of closing down the game, we're getting to a different state. And now for this state to work properly, I need a few more graphics. And this is going to work in the init method. So in here, I'm going to add one final section that I called menu. And in here, we get self.menu_surface. and I want self.menu_rect. And really all I'm going to do in here is pygame.image.load. And for this one, we just need another string to graphics.ui/menu.png. And don't forget, we need convert_alpha as always. And just to demonstrate what we are getting, here's again the game folder. We go to graphics, we go to UI, and there we have this menu thing. So that's what we're importing. All right, and next up, for the menu rectangle, we are just going to get self.menu_surface.get_rect. And this I want to place square in the center of the window. So center is going to be my window width over 2 and my window height over 2. And the basic idea is, if self.active is equal to false, I want to display this menu here. And I guess what I haven't done for this project is this thing doesn't have any scaling right now. So if the game gets really large, this might look very, very small. But that's something you can, well, work on yourself. All you would really need to do is get this scale factor and apply it to this menu surface as well. It should be fairly easy to implement. Okay, now, the basic idea of what I want to do is further down here, that if self.active, then I want to check for self.collisions. And this is what I have done so far up here. But this I only want to do if the game is active. So I want to remove this one, which really just means that I am going to delete this line. And let me put it on another line so it looks a bit cleaner. Now, if that is not the case, I want to self.display surface.split and self.menu surface and self.menu rectangle. So the basic idea is, if the game is active, we're checking for collisions. If not, we are splitting the menu. And if we run all of this, the game is still working, but now if I crash, we can see our logo. And this is working quite well. We can't do anything with it right now, but it does work at the very least. Also, the score keeps on running, so that's stuff we have to work on. But I guess step by step. Let's start working on the score. I guess that's the most important one. And this is going to happen in the display score again here. And basically what I want to do, this score should only update if the game is active. So all of this should be in if self.active, and only if that is the case, we want to get a new score. And I guess while we are here, we can also implement something else. That while the game is active, I want the score to be on top of the window. But if the game is not active, I want the score to be below the menu. And that we can also work in this method here. And basically all we have to work with is right now we have our window height divided by 10. And this is in the top middle part of the window. I want to cut this thing out and change it to a Y. And now if the game is active, I'm going to set this Y to the same number. So far, this wouldn't really be a difference. But what I can do now, I can set an else statement. And in here, Y should be a different position. And what I went with is window height divided by 2. And this is right now the exact middle of the window. And I want an offset to be a bit below that. And to get this offset, I want my menu rectangle and the height of that. And well, basically what we are doing is this here, again, is our entire window. This would be the center of the window. And we want to go down by the height of the menu. So the height of the menu rectangle. That's basically all we're going to do here. And I guess let's try if this is working. So if I run the code now, the game is still working. And if I crash into something, we can see a number below the menu now. And it's, well, not counting anymore. Although I guess the number is a bit too far down. So I want to move it up a tiny bit. And to achieve that, I'm going to divide this number by, let's say, 1.5. And let's put it in brackets. That should look a bit better. So now let's try this again. Game is still working just fine. If I now crash into something, this is looking much better. Cool. So now we have the score almost working properly. There's going to be one more thing we do have to work on. But for now, I'm happy with this. Now, I guess next up, we can work on restarting the game, because right now we can't really do anything. And for that, we have to look at the event loop. So all of this stuff here. And basically what I want to achieve is when the player presses the mouse button, I want to restart the game. So inside of this if statement, I need another if statement. That if self.active, so if the game is active and I press the mouse button, I want the plane to jump. But if that is not the case, so else, I want set self.active to true. Let's actually see what we get. So if I run the game, it's still working, but if I crash now, we, well, get nothing. And the game continues after I press. And I think if I press fast enough, there you can see if I think press fast enough, you can kind of tell the idea. Okay, now, what is the problem? Basically, let me draw it. This here is our game window. And the problem we have right now is if we stop the game, the plane continues to exist and keeps on going downwards. And once we are restarting the game, the plane is still down here somewhere. And since all of our obstacles are here and here and here, the plane doesn't reach them whatsoever. And as a consequence, the game keeps on running, but we can't see the plane. So that is something we have to work on. And in my case, here's how I approach this. In my collision method, after we have a collision, I am destroying the plane. So self.plane.kill. And then when we are clicking to create a new game, so down here, I am creating a whole new instance of the plane. So self.plane is equal to plane. And let me actually copy this from earlier. We just need this line here. And with that, let's try this again. So the game is still working. Now I crash into something, and now my plane is, well, at least in the right position back. The problem we have now is that we keep on having all of the obstacles in the game, which is kind of unfair if you are just spawning a new game. Also, the score doesn't start at 0, it starts at the previous score. So the score keeps on rising. So there are two things we have to work on. I guess we can start working on the obstacles. That's the easier, well, both are really easy, but let's work on the obstacles first. So essentially what I want to do. Once we have a collision, I want to destroy all of the obstacles. And this happens again in the obstacle class. And really all I want to do here is for sprite in self.collision sprites.sprites, I want to sprite.kill. And also in my timer. So in this timer here, I only want to spawn new obstacles if the timer is running out and self.active is true. So that way we are not spawning any new obstacles and we are destroying all the existing obstacles. Although right now there's a bit of a problem if we are doing that. Let me run the code to demonstrate. So the game is still working, but now if I crash into something, we are also losing the ground. And if I now click again, it, well, doesn't come back, which isn't ideal. And the problem here is that in my sprites, let me minimize all of those, my ground and my obstacle are all in the same sprite group, which is causing the problem here. And I think the easiest way to fix this is I want to give each of these sprites a sprite type. And then in here, if sprite.sprite underscore type is equal to obstacle, that is horrible spelling, obstacle, only then do I want to kill the sprite. So now in my sprites, I have to give them different sprite types. And this we can do straight at the top. So in here, self.sprite underscore type is going to be, let's call this one ground. And then for the obstacle, this could be self.sprite underscore type is going to be obstacle. And now we should be good to go. Let's try this again now. And now if I crash into something, the obstacles disappear, but the ground remains. And now if I restart the game, this is looking much better. Cool. So this seems to be working quite well. If I crash again, this same thing happens again. Cool. This is working. Now the final problem we have is the score, because this one doesn't go back to 0, instead it keeps on updating. And the problem here happens in this line. Pygame.time.getTicks gets the time since the program or our game has started. It doesn't really care what we are doing in the game. It's always starting from 0 whenever we start our program. So we have to account for that. And to account for that, here's what I have done. Is the score is always going to be offset by I call this the start offset. That is, I'm getting worse at spelling. And this start offset is just another time when the game became active again. So if we're starting the game at 2 seconds, start offset is going to be 2000. So 2 seconds in milliseconds. And this start offset we get down here. So all I want to do is self.start offset is going to be pygame.time.get_ticks. And obviously we also need the same number up here. Up here we need self.start offset, and by default it's going to be 0. And now let's try all of this. And now the time keeps on working. I get 2 for the score. And now if we start again, we start again at 0. So this is working pretty well. Cool. I'm quite happy with this. And I can crash again. And this keeps on working really well. Cool. So with that, we have our score and our game over screen. So the last thing we are going to need are 2 sound effects. And those are incredibly simple. Let's go straight into our code and let's work on them. Here we are back in main.py and we want to add some sound. And let me just demonstrate what we have. So in our third folder we have sounds, and in here we have jump and we have music. And that's kind of all we need. Let's start with the jump sound, although it doesn't really matter which one you start with. And I can minimize everything else in here. And in the init method of the plane, I want to add some sound. So all the way at the end, I want to add some sound here. And all we really need is let's call it jump sound. And to import music, we need pygame.mixer.sound. And now we need a path to the sound file, which in my case is going 1 folder up. Then we have sounds, and then we have jump.wav. And now before we are going to use that sound by itself, it's kind of loud. So I want to set self.jumpSound.set_volume to 0.3. In this set volume, 1 would be the maximum and 0 would be, well, 0. And in this case, 0.3 means 30% of the original volume. And now I just have to play this sound whenever we jump. And we know we jump when we are running the jump method. That kind of makes sense. So in here, I just want to run self.jumpSound.play. And that should be all we needed. Although I just realized this should be jump.wav, not slash. And now let's try this and let's see what we get. And well, that is working, except it feels absolutely horrible. But that's only because we don't have any kind of background music right now, but that we can fix quite easily. And that's going to happen in the main file. And this could be a pretty good exercise for you as well. So add the background music yourself and see how far you get. All we need is, first of all, I want to add another section in here. I think this one is going to be the final one now. And in here, I want self. Let's just call it music. And this is going to be, again, pygame.mixer.sound. And the path here is, again, a string. We go up, sounds, and then here we have music.wav. And I'm happy with the volume here. And to play this one, I just want straight away self.music.play. And the really important thing for this one is we need to add one argument in here, and that is loops. That should be -1. And this one tells Pygame to play this music perpetually, so we never stop, and we play it in a loop. So if I run the game now, okay, that works really well. So I hope this tutorial was useful, and I will see you around.